Okay, hello everyone. So for this little video, I wanted to just show off what objects are in Python and kind of get into this idea of object-oriented programming. So up here, without delving too far into it, because Chapter 2 does it more. But I kind of want to show what you're going to be doing and these types of classes and types that you'll see in Python. So Python is an object-oriented language, meaning all variables or everything we create in it is an object. Object-oriented is a paradigm where everything you create is in itself an object with attributes and features, and we can do some operations on them. So I usually have to use analogies when we're looking at these, but you can consider all humans objects, and then we have these functions like speak, walk, talk, listen, and we also have attributes a part of ourselves, right? Like eye color, hair color, height, weight. So all of these can be kind of referenced to an object that we'll create later, but just kind of keep this in the back of your mind here. So I'm actually going to go ahead and open up my my Python idle shell. Let me see if you can see that. Yeah. One thing, I'll make my font a tiny bit bigger here, just for our purposes. One thing you'll notice here is that a shell has the three arrows on the side. So if you're familiar with Python already, this kind of automatically runs whatever code that you have. So let's just say that I want to use this as a calculator. I could do 10 plus 5, and if I click the Enter keyboard on my keyboard, I will get 15 there. One other thing that you could do is if you go up to File and New File, and you're most likely going to do this once you get to the assignments, you can come up here. And if I do something like a print statement, which is what we'll see later, you can see it's purple. I'll talk about that soon. If I do print 5 plus 10, if I click enter, I'm just going to go down one level. So to actually run this code, I'm going to save my code. I'll just save it to my desktop. I'll do one practice. It's called objects. I'll save it. And then what I'm going to go do is go to run. And then I'm going to hit run module. And you can see here that now I'm running my code in the back end there. I'll keep this guy open for later once we want to get back to it. But for now, I'm just going to go ahead and take a look at, excuse me, my code right here. So inside of my, the book talks about this too. I have some screenshots from there. But one thing you'll notice is that it says all variables are objects, and it kind of gives this nice diagram of when we create a variable, x equals 5, it's going to mean two things. It's that x is an identifier for the object 5. So all we're doing here in Python is pointing to objects that exist inside of Python. You kind of think of it, if you kind of think of Python as this big stack of containing all these numbers, 1 to a million or something, we could say these variables x, y, and z point to them at different locations. So all these are actually just references to an object of a certain type. So you can see here, temperature references float right here, and we can create new ones as well. So what this actually means is that if I hit x is equal to 5, like so, and I type x, so x isn't the object itself of 5, it's just a reference to that object of, okay? So 5 is an object of an integer type, but x is the reference to it. So one more thing we could do here is if I type in the word type, type, and I open it up with a parenthesis, like so, it's going to tell me the object's type. So if I go ahead and press X inside of here, I have a class of int. If I do type of 5, I also get a class of int, okay? One thing is that these two aren't necessarily interchangeable. You'll get into more semantics of it, but essentially X is a reference to the object 5. So left side is your reference, right side is the actual object. Cool. Now, one thing that you might notice that is different here than in other classes is that Python is dynamically typed. So if I do int of y is equal to 5, I actually can't do this because Python doesn't really care about declaring the type. All it cares about is what's after the equal sign. So if I do y of 5 like so, and I do y of 5.2, it won't matter to it. And if I actually type out the type of y, it's going to be a float now, which is the other class that we have. And again, even though x is kind of set into place as an int already, if I do x of 10.0 and I do my type of x, it would be a float, okay? I'm going to put x back to 5 here, and I'm going to do x Let me do a variable called x1. I'm going to call it 5 as well. So we can see here, if I change my x around, like so, my other variable will still be the same version. That went a little faster, but essentially, if I create x is equal to 5, I create another variable equal to 5, these won't be modified by each other. One more thing is like this type of the order of operations or the sequencing of your code does matter. So let's just say I have a is equal to 2, and I say something like b is equal to a. Okay. So A has to be declared first, otherwise that reference won't exist. But B is now going to be declared. But let's just say that I say A is equal to 4 now. So what will our value of B be in this scenario, right? So if I type out A, okay, it's a 4. But if I type out B here, it's still 2, right? Because B was instantiated when A was still having the reference to the value 2. But now it only changed after it. So always think of when you're doing Python as like you're reading a scroll from top to bottom. And every time you hit a line in your scroll, it's going to do that operation right away. This isn't like the static type languages where everything needs to be perfect at the start. Python is dynamic, so it's going to do a run of your objects until it hits an error. Cool. So I won't go through all of these here, but there's some reserved keywords. And essentially what this means, some of these you're probably familiar with, is that I can't do something like false is equal to 4, right? So these variables are something I can't use. There's quite a few of them, but we'll get into why they're reserved later. But essentially to help build up our programs, these guys over here are the commonly used built-in classes for Python. So we'll look at the bool, int, and float and string in a bit because they're a bit more unique as well. But you can see here we have a list, tuple, frozen set, dictionary, and a boolean. So that's all good. Now you might notice this thing on the right side is something saying that it's immutable. So what this means is that the value won't be able to change after it's created, right? So when we say that the integer is immutable, we're not technically saying, this might be a little confusing because if I do x is equal to 5, right? And I have a type of x and it's an integer, but then I do x is equal to 6 or x is equal to false, like here, and I do type of x, it's a Boolean, so you might be thinking, well, I just changed the integer of x, right? That was an integer type and now it's mutable. What we're trying to say is that the 5 itself isn't mutable, so these won't be able to change. The thing on the right side of your expression after the equal sign isn't changeable. Now, what this means is that these objects, such as a list, a set, and a dictionary, are changeable. So what we mean by that then is that if I do x is equal to, and I'll go into lists in a little bit more detail later, but some of us might have seen them later. It's a bracket that opens, and then I have 1, 2, 3 inside of them. I could do x dot, I think it's append here. Let me see here, a 4. And now x is changed into 1, 2, 3, 4. So my previous object is actually mutable. I'm able to modify it, and that's the same with dictionary and list here. Okay. Let me go ahead and just rerun my program here one more time so I get a fresh one. Cool. So that's a pretty brief rundown of these objects here. The next thing that we're going to look at are our Python primitive classes. So essentially primitive classes, you can kind of think of them as the guys that are first ones around. They're going to be what build up all the other classes. We saw earlier that there's some built-in classes here too, but primitive essentially are always going to be int, float, string, and boolean. And whichever language you use, those are going to be your primitive types for it. Okay. So if we take a look at what each of these are, I could do something like x int is equal to 5. So that's my integer. I'll do x float is equal to 5.5. So anything with a decimal is going to be a float. X bool is going to be either true. And you can see here that my true is orange. There's actually a keyword for it, or false, right? So I'll do false in this one. And then finally, I'm going to do x string, str, and that's going to be where I use my double quotes or single quotes in order to make a string, right? So I'm going to say John for my string. One thing about if you're wondering why you should use a double versus single is that if I put John in here and you're going through a text file, let's just say that you find something like this, John's, that's going to be a problem. So what you're going to want to do is just put your double quotes like this, right? So now that's my string. Okay, and then if we go through all these types, we can see here that I have my primitive types. Okay, so essentially all of these are built off of each other. Now, what's the difference here with Python in comparison to other languages is that depending on what you're doing, is that you can actually kind of combine some of these types. So x in plus x float will actually be 5 plus 5.0. What's the type outcome of this one? We can see it here. The type of x in plus x float is a float, okay? Because we're adding those two values together. Now, what about x int plus x bool? That will actually work for us. Oops. Let me try to restart my shell here. There we go. X int plus x bool is a 5. So that's just going to do 5 plus false, which is 5. And then we could do x int plus an x string. Now here's where we get this error you might run into a bit called a type error. But if I do x int times x string, you see that I repeat my string 5 times, right? So it's 5 times John's, which is a string. So Python could be a little tricky when it comes to this because in other static languages, it will tell us that you can't do this operation. But in Python here, we're able to go ahead and create these objects pretty well. Cool. So let me pull up one more thing here for us. One more thing that I wanted us to look at. Here we go. So we kind of look through these guys, is this list class. So lists are a little bit different than what you might be used to, especially if you did MATLAB. So if we go ahead and run this guy one more time. A list is an object that's, it's an object that stores other objects as well. So you can have a list of lists as well for it. So I'm going to go ahead and just create a variable called LST. I'll just call it X right now. And to create a list, I'm going to put these two brackets, right? So if I do type of X, it's a class of list, X dot length, I think that, oops, length of X, sorry, this is a different language, is a 0 because there's nothing in it. Now I'll go ahead and say, let me go ahead and say X is equal to a list of 5, 6, 7. And here's the really cool thing about lists. Let me just do test. Go. Oops, I think I forgot one thing. Because I forgot the equal sign right there. Say I did on purpose. So right here, we can see here that our list contains different types of objects, right? So again, Python isn't type safe. So you could just kind of put in what you'd like here. And what we could see here is I have a 5, 6, 7. Now, how do I actually access the objects in there? So I have 7 objects that were within my list. Oops, sorry, I have too many screens. The way to access lists is using indices, okay? So lists are 0th index, so that means we start counting from 0. So what I can do here is if I type in X and I open up another bracket like this, and I type in a 0, like so, you'll see I actually get a 5 out, right? So if this is 0, what is this one going to be? Well, let's try it out. If it's 1, that's 1. What's this one over here? That's 2, right? So what this is saying to me is give me the object that's at X of index 2. So in my list at index 2, give me this object. And we'll see later on when we do a for loop, there's a few ways that you can iterate through these that are a bit different, okay? So for instance, we could have these type of values. Let me do X of 4, like so, and that'll be false. Now you can also do backwards indexing. So essentially, because 0 is at the very start, if we go out to -1, it will be a 6.8, and then we just kind of return through the other way, -2, and that will push us back into the other direction. Don't need to worry about that. I wouldn't even do it. It gets a little confusing. The main thing I want everyone to take away is that X is 0 is your start. So your first item in your list is at the 0th index. Okay. And then we'll explain why we go through that in a bit. And then, of course, we have these other built-in classes, but this should give you this type of idea from it. Now you could do some kind of crazy expressions with this as well. So I could do something like 5 plus x of 0. So let me do it this way. So this gives me this one. So let me try to do x 0 plus 5. And then this whole thing is going to be times x of, let me see here, 0, 1, 2, 3. So that's the third index, x of index 3. And then I get test 10 times. Okay. Now I could do x of 4. That's a false, and so forth, right? So just make sure you're aware of these things here and how to create them. And these are kind of your overview of your objects in Python.